Okay, let's go through Chapter 5, Section 1. Yesterday we hit just the properties of natural logs. So today we get to work with the derivatives of natural logs, which really aren't too bad. So what rules are we going to follow for derivatives of natural logs? Well, Theorem 5.3 out of the book says the derivative of a natural log function, while we let u be some differentiable function of x. Basically, that's saying we have some f of x function that we're going to let be u, just for symbolic purposes here. The very simplest natural log function would be natural log of x. And the derivative of that is simply 1 over x. Sounds pretty easy, huh? There is one quality where we have to pay attention. X has to be greater than 0, because if x is not bigger than 0, we would get a natural log of some negative. And it is not possible to find e raised to some power that would equal a negative number. We discussed that yesterday. So yeah, that gives us this condition that x has to be greater than 0. That is the simplest version. Now, what if our function isn't as simple as just x? And you'll see here, the first thing I'm going to have us do is like 5x, or the natural log of x cubed plus x. So definitely we'll look at more difficult cases. In that case, what we're going to do is say, well, there's some function out there. The natural log of some function will be 1 over u. Well, that has a lot of similarity with this, doesn't it? 1 over the box. 1 over the box. Yeah. So it becomes 1 over u. But then the good old chain rule kicks in, and we have to take the derivative of the inside function. This natural log of u could be written with parentheses. I could say natural log of u. That becomes 1 over u times the chain rule of the derivative of the function. So we pick up u prime. Many people will memorize this as u prime over u. And you can think of it that way too. Same condition, u has to be greater than 0. I must have, this function being bigger than 0. So, ideally, or generally, this will be the one that we end up committing to memory. Theorem 5.4 talks about, well, what if the derivative involves an absolute value? If u is a differentiable function of x such that u does not equal 0, then d dx, the derivative with respect to x, of natural log absolute value u is the same exact pattern that we just discussed up here. It's still 1 over u times u prime, chain rule for the u prime here. You'll memorize this as just u prime over u. So we don't need to learn anything different just because it's an absolute value. What this absolute value does allow is for a little bit broader function. Our function just doesn't have to equal 0, where here the function had to be greater than 0 at all times. The reason we can be negative in this case is that I have the absolute values going on. So if I happen to slip in with some negative function, well, the absolute value is going to pull it back to being positive. So nothing real special about absolute value, just a little bit broader case. Oops, empty page. So I have 5 problems that we're going to work through. This will go relatively quickly, and then you can be into doing some homework. So first problem, the derivative with respect to x of natural log of 5x. That 5x is our function, isn't it? I think of the u being 5x. And we just had seen on the previous screen, and you have this right above because you're on your note sheet, the derivative of natural log u will be u prime over u. So we just have to fit that pattern. So if u is 5x, then the derivative of this becomes 5x on the bottom, because that is the u. And then I do the chain rule for the top, and the derivative of 5x, I'm just going to show it. I need to take its derivative. Well, that becomes 5 over 5x. Cancel it out, I get 1 over x. So my answer is 1 over x. Practice another one of these. Take the derivative of natural log. You've got some space, I think. Natural log of 7x. If I take the derivative of this, u prime over u. Get that in your head. U prime over u. This is my u, 7x. The derivative of 7x then over 7x. That turns out to be 7 over 7x, which turns out to be 1 over x. Wow, there's a lot of similarity between that problem and the natural log of 5x. I wonder if everyone would be that way. All right, problem B. Find y prime and y is equal to the natural log of x cubed plus x. Now, I've got an extra set of brackets here. Don't really need those, do we? We could imagine those being gone. So not really totally necessary. What is my u? See if you can identify u. U is the inside piece of the natural log. So there's our u. Let's go into y prime. Y prime equals u prime over u. So here's the u. We want to take its derivative on top, divide it by x cubed plus x. Simple, isn't it? So derivative on top, nothing more than the power rule. 3x squared plus 1. And then no derivative on the bottom. It is simply just u. Step back, take a look. Can I simplify that function? Pretty sure I can't. So final answer, y prime equals 3x squared plus 1 over x cubed plus x. I hope you're thinking this is not too bad. It really isn't, is it? We can use trig functions, and here we got a trig function with an absolute value. The only time we'd have difficulty is if the sign of x turned out to be 0, such as sine of 0 is 0, sine of pi is 0, sine of 2 pi is 0. Those ones we would have domain issues. But in general terms, our u is going to be simply the sine of x, isn't it? And we go into our pattern of u prime over u. So I'm going to say that y prime is equal to u prime, so the derivative of sine x over sine x. And remember, these absolute value signs do not create a different pattern. It's still u prime over u. Now, derivative of the top, all you got to do is remember your trig functions. Derivative of sine is cosine, and then it's just over sine. There is one little thing I could do here. We could simplify cosine over sine. Do you remember from pre-calc? Cosine over sine is what defines the cotangent of x. So we could simplify that out to cotan. And this was just a little trig identity. Mrs. Zabel and Mrs. McNamara would be so proud of you if you could remember that. All right, letter D. Oh, little hint going on this one. Use the product rule. Why must I use the product rule? Well, I have x times natural log of x. That describes a multiplication scenario. So let's go into our good old product rule. Derivative of the first times the second plus derivative of the second times the first. Or some of you have memorized it as u prime v plus v prime u. That's what we're after here. I think to make things simpler, let's just get the structure set up and then we'll do the work. So the structure will be, I need to take the derivative of x, multiply it by natural log x. Add it with the derivative of the second, or v prime. How am I going to show this? Parentheses with a prime symbol showing I need to take its derivative, and then multiply it by u, which is x. All right. Now let's actually do the work. I'll change colors. y prime equals, the derivative of natural log is simply 1. Did I say natural log? The derivative of x is 1 times natural log. That was easy. The next one, the derivative of natural log x is u prime over u, where this is u. So the derivative of x over x times, this just simply slips down, doesn't it, times x. All right, I'm making a lot of work out of this, but I'm hoping it makes it nice and clear for you. Derivative of x is 1. I have that sitting over x multiplied by x. Well, x over x will cancel, and that gives me just 1. So our bottom line, most simplified form is natural log of x plus 1. Now, you know, I took more steps than I probably really needed to, but we're doing it on a recording, and I think that way things make it are more obvious here of what transpired. Okay, the last one. Ooh, I saw chain rule. Don't get scared. It'll be okay. Chain rule. We have that outer power of the fourth. So there really are two levels to this function. And I'm thinking I've already spotted it. We have something raised to the fourth, and then we go to the, oh, this is gonna be tough. The inner function. I'm gonna make my inner function, whoops, not inner function. I'm gonna make it natural log of 3x squared. Because we've been treating this all along as, that's what we've been doing, is just the derivative of the natural log of something. And we'll be able to handle that. All right, so we start on our outer function, don't we? Y prime will be y prime. 4 comes down, changes to a 3, power rule, of the inside function that we just leave alone, don't we? We always called it the blob. 4 times the blob raised to the third. Chain off, so times. Now we take the derivative of the inner, and this is our new little piece we've learned. Here's our u, and then we've got, we know the pattern is u prime over u. So I need to take the derivative of 3x squared and put it over u, which is 3x squared. So my next line, I'm going to make this 4 natural log of 3x squared. And you know what? You really do need this extra set of parentheses to show that it's the natural log cubed and not 3x squared cubed. Derivative of the top of this would be 6x sitting over 3x squared, which will simplify. 3 goes into 6 twice. X goes into x squared x times. All right, that will get us an answer of y prime equals. Do you see how I can take the 2 and multiply it by the 4 and get 8? Natural log of 3x squared, quantity cubed, over x. And that x is coming from that guy right there. Final answer there. All right, those were 5 nice examples, and homework will be similar. And you know what? I didn't have the next screen be the homework, so I'm going to have the homework written up on the board, and it will be on the back side of your notes. So good luck. Make sure that you have your natural log one done from yesterday, just on properties, and have this derivative one done for Monday. See you then. Okay, also, hey, word to Luke, Zach, Peter, Tucker, Logan, Luke, behave.